This is lecture 9, material handling for IE 4355 facilities planning. The objectives for this course are listed in this slide. And as always, we want to correlate these objectives with the lecture. So as you can see in that first objective, we want to develop an understanding of the principles of facilities location, layout, and material handling systems, and to practice designing facilities. And also objective number 3 focuses on learning the fundamental principles of material handling, which is what we are going to be doing in this lecture. So the agenda for today's lecture, we're going to provide an introduction on material handling, and then we're gonna spend the rest of the lecture looking at different type of equipment for material handling. The learning objectives for today's lecture is to learn about for some of the material handling equipment requirements into a facility. So let's look at the introduction. If you remember from our first lecture, we showed this diagram. And as you can see, one of the pieces towards the end of this diagram is the handling system design. So today we're going to be focusing on that piece. When we look at facilities design from the perspective of these two pieces for facilities planning, we have already mentioned or discussed the structural design, the layout design, and now we are focusing on the handling system design. So the components of material handling, the materials, which are products, items, substances, and or people which are being moved, transported, or physically relocated. The move to be made, which includes the origin, the travel path, the destination, and the frequency. And the method to be used to make the move, which involves equipment, people, procedures, and physical facilities. So in this diagram, we have at the bottom here, we have the material handling equation that involve what, where, and when is going to be equal to how and who, which is the method. As you can see here, where and when includes the move. So the material plus the move equals the method. So we are going to be looking at this piece of material and move in order to achieve our goals. The material handling taxonomy is listed here. This is coming from the College Industry Council on Material Handling Education. And we have material handling equipment in terms of transport equipment. We have conveyors, cranes, industrial trucks, or no equipment. We have positioning equipment, unit load formation equipment, storage equipment, and identification and control. So let's look at some of the material handling equipment. Material handling equipment is used for the movement and storage of material within a facility or at a site. Material handling equipment can be classified into the following 5 major categories. Transport equipment is number 1. This is the equipment used to move material from one location to another. And the major subcategories of transport equipment are conveyors, cranes, and industrial trucks. Material can also be transported manually using no equipment. So this is transport equipment. Number 2 is positioning equipment. This is equipment used to handle material at a single location so that it is in the correct position for subsequent handling, machining, transport, or storage. Unlike transport equipment, Positioning equipment is usually used for handling at a single workplace. Material can also be positioned manually using no equipment, as we mentioned for the first group. Number 3 is a unit load formation equipment. This is equipment used to restrict materials so that they maintain their integrity when handled as a single load during transport and for storage. If materials are self-restrained, for example, a single part or interlocking parts, then they can be formed into a unit load with no equipment. Number 4 is the storage equipment. This is used for holding or buffering materials over a period of time. Some storage equipment may include the transport of materials, for example, the SR machines of an ASRS or the storage carousels. If materials are block stacked directly on the floor, then no storage equipment is required. Number 5 is the identification and control equipment. This is equipment used to collect and communicate the information that is used to coordinate the flow of materials within a facility and between the facility and its suppliers and customers. The identification of materials and associated control can be performed manually with no specialized equipment. So in terms of transport equipment, which was our first category, the major subcategories of transport equipment are conveyors, cranes, industrial trucks, or no equipment. The conveyors these are commonly seen in manufacturing floors. This is equipment used to move materials over a fixed path between specific points. Cranes, these are heavy-duty equipment used to move materials over a variable path within a restricted area. And industrial trucks are also common in warehouses, equipment used to move materials over a variable path with no restriction on the area covered by the movement or no equipment. So that means that you can transport manually. So transport equipment, again, cranes have a variable path plus a restricted area. Industrial trucks have variable path and unrestricted area, and conveyors have a fixed path. So that will be the difference among the three. In terms of conveyors, conveyors are used when material is to be moved frequently between specific points to move materials over a fixed path and when there is a sufficient flow volume to justify the fixed conveyor investment. Conveyors can be classified in different ways. First, type of product being handled, unit load or bulk load, the location of the conveyor, or whether or not loads can be accumulate on the conveyor. So there's a list of different type of conveyors. There are listed here. We are going to talk about some of them in this lecture, but as you can see, the list is big. So it will depend on the type of product that you're moving and the type of constraints that you have for your production. So here's some examples. This is a chute conveyor. See, it looks like so it's mostly based on gravity. Then the wheel conveyor, something that you can move around. There's two types. So this one that can be transported to different places, and this other one at the top has to be fixed. Gravity conveyor, chain conveyor, and live roller conveyor. So it has some type of engine here or motor to move the conveyor belts. Transport equipment conveyor, the slack conveyor, those are typically seen in those distribution centers. So for example, UPS, they receive these boxes and they need to be split into different trucks. So you will see that slack conveyor. Magnetic belt conveyor, those are specifically for products that are to be sorted or that they have some type of property. And the flat belt conveyor is very common. This has a flat surface that can move different type of products. Transport equipment conveyors, the throw head belt conveyor, the vibrating conveyor that's helpful in terms of packaging, and the bucket conveyor, again, also helpful for packaging and movement of product. Transportation equipment conveyors, the loop face pneumatic conveyor, the screw conveyor, and the carrier system pneumatic conveyor that is typically seen in the banks auto service. So you have this capsule going through this dock that's moved by air. Transport equipment conveyors. So again, a lot of different types. Reciprocating vertical conveyor, those are common in warehouses, distribution centers. Transport equipment conveyors. Here we have the trolley type of conveyor in which you have a belt at the top and then you're moving your product. Product is hanging. So you have a change, you have a carrier, and then hanging, you have the load. More information about those. So we have the power and free conveyor, and we have the monorail. They have this specific fixed trail that you have to follow. More conveyors here. The sortation conveyor, very common, like in industries like Amazon and UPS, in which you have all these boxes and they have to be sorted depending on where they're going and which truck is gonna transport them to the final location. Sortation conveyors, we have the pop-up device. Again, it will depend on the needs. So sometimes you have some sensors in these conveyors and they will read a car or some type of code in your boxes. So when you receive these packages from Amazon, you see that you have different codes on top of the box, on the tape that is coming in the box. So that information is used for sortation purposes. So more sortation here. We have the tilting device and we have the cross-belt transfer device. So here we have the transport equipment cranes. General characteristics of cranes, they're used to move loads over variable paths within a restricted area. And they're used when there is a insufficient flow volume, such as the use of a conveyor cannot be justified. Provide more flexibility in movement than conveyors. Provide less flexibility in movement than industrial trucks. And loads handled are more varied with respect to their shape and weight than those handled by a conveyor. Most cranes utilize hoists for vertical movement, although manipulators can be used if precise positioning of the load is required. So cranes are used to move materials over a variable path within a restricted area. So the major type of cranes are the jib crane, bridge crane, gantry crane, and the stacker crane. So here's the jib crane, the bridge crane, and the stacker crane. So you can see the difference between them. So again, it will depend on the type of environment that you're working in and the space that you have available to set up such type of equipment. But their goal is essentially the same. You have a load that you have to move within a fixed or variable path. So depending on the flexibility that you have and the space, then you might choose the best equipment. So here there's some different configurations for the cranes. So in terms of industrial trucks, these are used to move materials over variable horizontal paths with no restrictions on the area cover. Provide vertical movement if the truck has the lifting capabilities. Is used when there is a insufficient or intermittent flow volumes, such as the use of a conveyor, cannot be justified. Provide more flexibility in movement than conveyors and cranes, and not licensed to travel on public roads. So for example, commercial trucks are licensed to travel on public roads. So here's again the list of different type of industrial trucks. So here's some examples. The industrial trucks, two-wheel handle truck, the floor hand truck. So these are pretty common. We have the industrial, the manual walkie stacker, the power walkie stacker, or the powered pallet jack. Here's a sit-down counterbalance lift truck. Those are very common. And the narrow aisle reach truck, these are common in warehouses. And the operator down turret truck. So the idea is the same. You have those fingers and they can go under the pallets, and then you can lift and you can move around. You don't have a fixed path, so you have the vehicle that you can drive to a desired location. Here's some extra examples. The AGVs, these are becoming more popular now. These with the use of new technology. So if you have a pad, they can follow the path on the floor to guide the vehicles. So these are common in auto industry. Amazon are using them to sort and move their products inside the warehouses and so on. Power industrial trucks. These trucks are used for moving either mixed or uniform loads over a various paths, or these paths can be somewhat random. At the discretion of the driver, the paths are restricted to suitable indoor or outdoor surfaces. Industrial trucks provide not only a means of transporting materials, but also provide a means of accurate lifting and stacking. Appropriate tooling for the truck permits users to lift not only pallets, but a wide array of specialized loads. For example, rolls of carpet are easily moved via industrial trucks by replacing standard forks with a single tube. Power industrial trucks can be found in almost any manufacturing plant, loading, dock, or warehouses. Internal combustion trucks add the advantage of outdoor use. They can lift between 2,000 and 15,000 pounds, with some specialty trucks lifting up to 50 tons. They can lift up to 20 feet in height and can operate on gasoline, LP gas, or diesel. The Industrial Truck Association has classified the power trucks into 7 classes, which are listed here: the electric motor rider trucks, the electric motor narrow aisle trucks, electric motor hand truck, internal combustion engine trucks, internal combustion engine trucks with pneumatic tires only, electric and internal combustion engine tow tractors, and rough terrain forklift lift trucks. Each of the classes are divided into lift codes. So see the ITA pictorial model listing. The first 5 classes are most common. Detailed information is available through the ITA. So the electric motor rider trucks are general purpose trucks and used primarily indoors. These trucks can lift up to 6 tons and up to 18 feet in height. The electric motor narrow aisle trucks are using narrow aisle applications. These trucks are used primarily for storage retrieval in applications similar to AS/RS function, and they can easily lift loads from 2,000 to 4,500 pounds to heights of 40 feet. Electric motors hand trucks are generally used for indoor applications and can handle up to 4 tons. These trucks are perfect for situations in which material is to be moved from one location to another without the need for lifting more than a few inches. For example, this type of truck is commonly used in grocery stores to move pallet loads of cans or boxes to a display location within the store. An added convenience is that the operator can move amongst customers in the store safely and without structured views. Internal combustion trucks have the advantage of outdoor use. They can lift between 2,000 to 15,000 pounds, with some specialty trucks lifting up to 50 tons. They can lift up to 20 feet in height and can operate on gasoline, LP gas, or diesel fuel. Internal combustion trucks have the advantage of outdoor use. So here's some of the codes. Power industrial trucks, class 1 electric motor rider trucks. So here are some of the codes. You don't have to memorize this. This is just for information. So in the future, you can refer back to these notes in case you need to. This is a class 2. So we have the 6 codes, lift codes for class number 2. Class number 3 has 8 codes. Class 4, we have less different codes here. So lift code 3 for class 4. Class 5 has lift code 4. Class 6 has lift code 1. And class 7 also lift code 1. So here's the ITA pictorial model listing for power industrial trucks. So as you can see, these are different type of finger trucks. Again, depending on the environment that you're working on and the purpose or the goals, you can pick up the one that better meets your needs. So you can see there's different configurations, and they have different type of engines and so on. And this is class 4, as we discussed. You can find more information about these trucks by going into this webpage. Positioning equipment. So it is used to handle material at a single location so that the material is in the correct position for subsequent handling, machining, transport, or storage. Unlike transport equipment, positioning equipment is usually used for handling at a single workspace or workplace. Material can also be positioned manually using no equipment. So as compared to manual handling, the use of positioning equipment can provide the following benefits. Raise the productivity of each worker when the frequency of handling is high. Improve product quality and limit damage to materials and equipment when the item handle is heavy or to hold. Reduce fatigue and injuries when the environment is hazardous or inaccessible. So here's a list of different positioning equipment. We're going to show some of them now. So we have the lift tilt turntable, shelves in terms of setting up your trucks in case for the dock leveler. And also we have the rotary index table that can help fix the materials of the product so that those robots can interact with them. We have the rigid link manipulator. Can help in terms of fixing some of the parts that you're working on or pull or hang. Part feeder. We have the air film device that can fill up and down to fix or to hold some of the equipment. Articulated chip cream manipulator. We have the vacuum manipulator, and we have some industrial robots. Unit load formation equipment. Unit load formation equipment is used to restrict materials so that they can maintain their integrity when handled a single load during transport and for storage. Advantages of unit loads: more items can be handled at the same time. Enables the use of standardized material equipment. Disadvantages of unit loads: time spent forming and breaking down the unit load. Cost of containers, pallets, and other load restraining materials using the unit load. empty containers pallet may need to be returned to their point of origin. So here's some list of unit load formation equipment. And now we're going to show some examples. So we have the slip sheet. We have the tote pans. Those are common in when you're moving. Say moving companies will use those, and the pallets are very common everywhere where you had to move certain amounts of product. Pallet boxes, kit boxes, and then the intermodal containers, those are very common as well. The robotic pick and place palletizer, the shrink wrap, stretch wrap, those are common in the airports as well, and the manual palletizing. Storage equipment, potential reasons for storage include time, friction, allow product to be available when it's needed. Processing, for some products, for example, the wine, storage can be considered as a processing operation because the product undergoes a required change during the storage. And then security, for example, nuclear waste storage. Here's some storage equipment. Now we're going to look at some of the examples. The selective pallet rack, very common. The drive-through rack, it's also common in warehouses. More on the flow-through rack. In this one, you have that decline, allows you to put products on the back, and then you can pull them easily from the front. The driving rack, you have space to transport and to move between the racks. The pushback rack and the sliding rack. So this one you can pull and push and then create that space in between as needed. The shelf, bins, drawers, and the storage carousel, those are common in HEB, UPS, not UPS, but Amazon and HEB use those storage carousels a lot. Milli-load ASRS and the unit loads ASRS. Split scale order picking system and the man on board ASRS. Identification and control equipment. This is used to collect and communicate the information that is used to coordinate the flow of materials within a facility and between the facility and its suppliers and customers. So here's some examples. Manual, no equipment. The identification materials are an associated communication can be performed manually with no specialized equipment. Although it is sometimes possible to manually coordinate the operation of material handling system, it becomes more difficult to do so as the speed, size, and complexity of the system increases. So barcodes are, as I mentioned earlier, unique bar space patterns represent various alphanumeric characters. Barcode system consists of barcode label, barcode scanner, and barcode printer. Contact barcode scanners use pen and wand to read the labels. No contact bar code scanners include fixed beam, moving beam, and omnidirectional. One-dimensional codes are most common. 2D codes enable much greater data storage capability. The RF tag, data encoded on chip encasing a tag. No contact can be read when the tag is within 30 feet of an antenna. Tags can either be attached to a container or permanently or temporarily to an item. RF tags have greater data storage capability than barcodes. The magnetic stripe, data encoded on a magnetic stripe that is readable in almost any environment, requires contact with a reader and greater storage capability and more expensive than barcodes. These are the stripes that you will see in these credit cards. Machine vision does not require explicit encoding of data since objects can be identified by their physical appearance. No contact, but typically requires structured lighting. more flexible than other identification equipment, but less robust. The portable data terminal, handheld, arm-mounted, vehicle-mounted data storage and communication device, communicates with a host computer via a radio frequency or infrared link. Variety of input devices available: keyboard, barcode, scanner, voice, headset. Electronic data interchange, EDI, Internet Electronic Data Interchange provides standards for intercorporate transfer of purchase orders, invoices, shipping notice, and other frequently used business documents. Prior to the Internet, EDI requires expensive dedicated value-added networks. EDI is critical for implementing just-in-time manufacturing. Deciding on a picking medium in picking operations. As part of warehousing operations, and specifically in picking operations, identification of the parts and their locations can have an impact on the picking speed. The following are the most commonly used mechanisms for communicating picks to order pickers: label picking, pick to light, radio frequency barcode picking, and voice picking. Material characteristics. Here are some categories and measures. So depending on these categories, then we can measure. So we have physical state, size, weight, shape, condition, safety, risk, and risk of damage. So in this slide, we are trying to give you a strategy to select the type of equipment that you will need based on the quantity of material moved and the move distance. So if your move distance is short and the quantity to move is low, then manual handling hand trucks will be enough. If the move distance is short and the quantity of material to be moved is high, then conveyors will be the best option. If the move distance is long and the material or the quantity of material is to be moved is low, then power trucks, unit low AGV are the best option. And if both of them are high, then conveyors, AGV train. Flow rate, again, another way to select equipment. So if the quantity is low, the distance is short, manual hand truck. So this is the same information that we show you summarized. The layout type, based on the equipment. So layout type, fixed position, process, and product. So we discussed this already. So if you're in a fixed position, then the typical material handling equipment are the cranes, hoists, industrial trucks. If it is a layout type that is a process layout type, then hand trucks, forklift trucks, and AGVs. If you have a product layout type, then conveyors for product flow, trucks to deliver the components to stations. In terms of safety and ergonomics, scientific research shows an increase in injuries at certain levels of exposure to heavy, frequent, awkward lifting. So job design is very important in creating a safe and healthy work environment, and the selection of proper material handling devices can help with reducing some of the material handling related injuries. So it's important to pay attention to this type of move: heavy lifting, frequent lifting, and outward lifting. So here's some ways to calculate lifting. Again, this mostly for educational purposes for your references. So at some point you need to learn or provide some feedback in terms of ergonomic design, which I believe for IE you have a course that look at this in detail. Then you can refer to these tools for computing the lifting amount for specific task. And these are the tools that you can use. Principles for reducing heavy lifting: reduce the weight, increase the weight, use mechanical assistance, slide instead of lift, and finally, team lifting. Also, use mechanical assistance, avoid unnecessary lifting, and use mobile storage. Principles for reducing awkward lifting: remove obstacles, slide closer, reduce shelf depth, reduce package size, use mechanical assistance, or team lifting. For bending, reduce the weight, increase the weight, depending on the process, use mechanical assistance, slide instead of lift, or team lifting. Principles for reducing upward lifting: reaching above shoulders, arrange storage, use mechanical assistance, or use a rolling stair or safety ladder. For twisting, use conveyors, provide more space, arrange storage. Principles for reducing duration of lifting: rotate the other jobs or to other jobs and use mechanical assistance. For more information on the ergonomics, you can visit the OSHA webpage. They provide a lot of information for occupational safety and health administration. So always remember, you have to make sure that you use the right equipment, and that you keep the people that work with you safe. So follow the safety guidelines, as you don't want to be involved in some of the situations shown in this slide. So that's all for today, and hope you have enjoyed this lecture on material handling equipment.